Hello. In this video, I will go over a solution for LeetCode 274 H-index. So the problem states, given an array of integers citations where citations at index I is the number of citations a researcher received for their ith paper, return the researcher's H-index. Now, this is the definition of H-index on Wikipedia. The H-index is defined as the maximum value of H, such that the given researcher has published at least H papers that have each been cited at least H times. So let's talk about the question. Let's use the example input and output. So, oops. Example gives 3, 0, 6, 1, 5. We can imagine each number representing a paper where this paper has 3 citations. This one has 0, this one has 6, this one has 1, and this one has 5, right? Now, the H-index is 3 because there are 3 papers where there are at least 3 citations. But there are not 4 papers where there are at least 4 citations because, in fact, these are the only 2 papers with at least 4 citations, right? So that doesn't work. Now let's talk about a solution for this problem. To me, one that quickly comes to mind is just making 2 for loops where you check. Uh, so in the first pass of the outer for loop, we would check 3 and see if there are 2 other papers with at least 3 citations. So in this case, when checking 0, no, 6, yes, 1, no, yes. So then we would say 3 is good, right? And then you can optimize this a little to skip all numbers less than 3 once you've found that the H-index is at least 3. So then we would check 6. And then we would check every number in the array. So 3, no, 0, no, 6, yes, that's counting itself. Oh my gosh, 1, no, 5, no. So no, H is less than 6. And we skip 1 because H is at least 3, and finally we check 5. So then we have 3, no, 0, no, 6, yes, 1, no, 5, yes. However, there are not 5 total papers with 5 or more citations, so in this case, 5 as an H index is not valid. So then we're left with 3. So let's think about this solution and the time complexity and what you usually aim to get for a optimal time complexity solution in a LeetCode question. So if we're iterating through most of the list, and then for each pass we iterate through the entire list, that is 2 for loops nested inside of each other. So then you're going to get an O of n squared time complexity. And normally the most you want is O of n log n. So that means O of n squared solution is definitely not optimal. Let's talk about another approach to this question. What if instead of looking at the raw array, we actually sorted it first? And then after sorting, we start with a pointer on the right. Okay, I know H is at least one because there is one paper with more than one citations, right? So one is a check. Now let's check two. We know there's at least two papers where there are at least two citations. Check three. And then we see that three is valid. Now once we check four, that's where we're like, wait, stop. One, this paper only has one citation. It does not have four citations. So we stop at H equals 3. Now, one thing I didn't say is that because the list is now sorted, when you are checking a new, like, when you move the pointer to the left, say from here to here, you know that all, like, papers, let's call them papers, or all elements of the array to the right of the pointer are greater than the element that the pointer is currently at. So if 5 is greater than 2, then we know all elements to the right of 5 are greater than 2. So that's why we wouldn't have to like check. For 1, we only check 6, and for 2, we wouldn't need to check 6 and then 5. We only need to check 5. So now with this solution, let's think about the time complexity. So to sort it, this is probably n log n on average. We're using like quick sort, let's say. Um, and then we need to traverse through the loop once. So that would be O of n. So that means this solution is overall big O n log n, because most of the time is dominated by when you're sorting the original list. That is better than O of n squared, the previous solution. All right. So now let's implement it. We say that h equals 0. And then we say citations. We want to sort citations, so we'll just sort it in place. Now we say for I in range. Now remember in the drawing, we wanted to iterate from the right. Call it a right pointer. So how would we do this? We would use for I in range length citations minus 1, because the length, for example, the length of this array is 5, but the rightmost index would be 4. Oops, 4. So we have to subtract 1, and then we want to stop at 0. So we'll put -1, and we want to move from right to left. So that means we're going backwards in the array, so each step in the range will have to be -1. Now we say if citations at index I is greater than h, oh my gosh, do that. We add 1 to h. And then just return h. Nice. Test case has got accepted. Let's submit and see if the solution is good. Awesome.